So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now, Climate Action Day
is on Thursday, November 6th.
Climate Action Day is a live online event produced by the Take Action Global Network. The event welcomes world leaders, climate scientists, youth activists, artists, and performers. Climate Action Day is designed for classrooms and schools. And I got interested in this event because the word action is in the title, and that's what we need. We need action to reverse global warming and its harmful effects, and not even only reverse. We need to slow it down. And there's a blizzard of actions that we can take, but only a few will have fast and widespread impact. Now, it's useful to have actual data on the actions that will have timely and successful impact on global warming. So I was kind of puzzled by this. There are all kinds of ideas like what's going to make the fastest, most effective, most cost-effective change. And so I bumped into this thing called En-ROADS. It's an online simulation tool, and it's the most useful tool that I've found to figure out how we should prioritize our activities and whether or not our activities are going to make the impact that we really require. So when I use this En-ROADS simulator, starting right now, and it's really easy to use. You can go to the website. It's free to use. When you look at that initial screen, the current En-ROADS trajectory of global warming, based on just continue what we're doing right now, it's going to result in global warming of 3.3 degrees C by 2100. Now, the international target, all these climate organizations and climate conferences and things like that, our international target was 1.5 degrees C. Now, unfortunately, we're not really making a big impact. We're not doing our job. And just last year in 2024, the global temperature went up by 1.55 degrees C in 2024. And these are measurements that are basically post-industrialization. So I suggest you try the En-ROADS simulator. It's easy to try different actions. Just move the slider on various measures to see the modeled impact on global temperature increases. So you can find out for yourself the most effective and timely actions that we can take. So let's look at some of the popular actions that we talk about that society is trying. It's, scientists and politicians, whatever, that we can try to reduce global warming. So one thing we can do is dramatically increase our fission and fusion nuclear reactor production. Build a lot of reactors really fast, both fission, which is working in conventional, we've used that, and fusions and new power plants. But here's the reality. Even for established nuclear power plant technology using fission, the last plant we built took 20 years and cost over $20 billion to build. That was the Vogtle plant, I think, in South Carolina. The cost for building these plants keeps going up. The cost for the nuclear fission materials keeps going up. And you kind of compare that to what's happening with renewables. The renewables cost, solar, batteries, wind, it keep going down really fast. So even if we were to spend the time and money to build more nuclear reactors, fission's the only practical one. Even if we were to do that, it would only reduce global warming by less than 1/10 of a degree C. Now, another idea, this is kind of intuitive. Hey, let's plant 1 trillion trees. Started off with 1 billion, but we really need more like 1 trillion. Trees take land, and the land is expensive. It's already being used for other things. Where, in fact, chopping down trees to make more land for people in farming, and finding the land for 1 trillion trees, it's going to be really hard. It's going to take a long time. And also, you got to remember, trees capture carbon dioxide, but only as long as those trees are still in a wood form. Once they decompose or they're burned, that carbon goes back into the air. So even if we were to plant 1 trillion trees, it's only going to reduce global warming by 1/10 of a degree C. Another idea is to change our food habits and farming methods to lower emissions. You know, fewer cow farts, less gasoline and kerosene and diesel fuel for tractors, things like that. So even if we were to do that, it's going to take a long time to change our diets because that's a cultural thing, and it's to change global agriculture. It's going to take a long time. But even if we were to do all that, it would only reduce global warming by 1/10 of a degree C. Now, another idea that has been out there, and mostly promoted by fossil fuel companies, is direct air capture of the CO2 that's already in the air. That's called DAC, direct air capture
There's currently 400 parts per million.
of CO2 in the air. And we can kind of take that out, bring it back down to like 100 or 50. Now, we can also eliminate the CO2 emissions that are coming from power plants. So there's smokestack scrubbers that will take that out. That's carbon capture and sequestration. Take the CO2 out. You got to put it somewhere so it never gets back into the atmosphere. These technologies are expensive. They are not even close to being scaled up. They're slower, and they require a lot more power simply to remove the CO2 or purge the CO2 in the smokestacks. So you'd have to basically burn a lot more fossil fuels to take out that CO2, which makes no sense at all. You're going to increase it. Or you'd have to use solar, wind, and batteries to power those DAC and CCS systems. And that's going to require a lot of electricity. You're better off just generating the power with solar and wind and storing in batteries. So even if we were to do that, it's going to change the global warming situation by 0.1 degree C. It's not really moving the needles. If we were to do all of those things together, it would only get the global warming down to 3 degrees C by 2100. We need to be at 1.55. We're currently at 3.3. All right. Now, let's flip the script. What are the actions that are going to have the biggest, fastest impact? The number one best thing we can do is put a high price on carbon, basically a carbon tax, or in California, we had a cap and trade programs, which are effectively the same thing. Basically what that does is it makes fossil fuels less economical. Basically, it's going to discourage industries and people from using fossil fuels. That will have the biggest impact. That will reduce global warming by 0.6 degrees C. Obviously, it's vehemently opposed by the fossil fuel industry. And so that's a big battle. But there's countries around the world that have taken these approaches and they're really making an impact. All right. Another thing we can do is increase our transportation efficiency. The best way to do that is, instead of using fossil fuels for transportation, electrify the vehicles with EVs, with batteries. Power is going to come from solar and wind. Even for planes, use hydrogen fuel. So there's ideas there. Feasibly, at some point in the future, we may even have battery powered planes. Now, if we were to do that, it reduces global warming by 0.2 degrees C. So we're kind of getting there. These are more productive. Another thing similar to transportation efficiency, if we increase the efficiency of our buildings and our industries. Buildings use a lot of fossil fuels for heating and cooling. And industries use a lot of fossil fuels for things like making steel or creating cement. Now, obviously, we can electrify buildings with heat pumps, and those heat pumps are going to be powered by wind and solar. And for industrial processes like making cement and making steel, we can use green hydrogen for industrial processes. Now, the green hydrogen is not moving as fast towards profitability as electrifying buildings with heat pumps, but it's going to get there. If we were to do that, increase building efficiency and industry efficiency, it'll reduce global warming by 0.3 degrees C. The last thing that's going to really have a big impact is stopping methane leaks and CO2 leaks. Now, CO2 leaks are from pipelines that are moving CO2 around or from capped wells. Methane leaks are usually from capped wells or pipelines where it's the natural gas that's leaking out of the ground. Every time there's an oil well or a natural gas well, you've got possibly a little bit of leakage, and there's some wells that just leaking like crazy. If we were to stop those leaks, which is not free, but not that difficult to do. Fossil fuel companies don't want to do it, but it's straightforward because we know where those wells are. That would reduce global warming by 0.3 degrees C. So if we were combined these biggest impact actions, high carbon price, increasing transportation efficiency, increasing building and industry efficiency, stopping methane leaks, that would combine to reduce global warming down to 2.2 degrees C by 2100. Now, It's still more than we're at right now with 1.5 degrees C, but boy, we are not making progress. The temperature keeps going up. Now, all these measures, that they're international, global changes, and every country around the world is going to have to pitch in to do that. But there's things that individuals can do, you and me, that are going to have an impact, not a really big impact. Sometimes it's a feel-good impact, but sometimes it's a healthy impact. Things like eating less meat, or growing your own vegetables, or riding a bicycle to work. And those are easy things that you and I can do if we want. Now, other things like investing in new technologies such as nuclear fusion, I'm not saying stop it. I'm saying I'm skeptical, but I'm not saying stop it. And maybe there's going to be a miracle with nuclear fusion. Maybe there's a miracle that's going to happen with direct air capture. Who knows? But we should continue to investigate those things. We can also start deploying technologies that are more likely to scale. I think it's much more likely that we're going to be able to scale small modular nuclear reactors than fusion reactors. So there's a bunch of companies that are coming out with small modular nuclear reactors. Let's see if that can scale. Now, we can't depend on it because it may turn out, and as the economics show us right now, it may turn out that solar, wind, and batteries are way cheaper, but maybe it'll work out. Now, that's where these En-ROAD simulations really help, and that's where you can see, hey, if we were to change things, with agriculture or biking to work and things like that, it's not going to move the needle on a global basis, but it'll definitely have some impact. So let's just kind of focus on things that the biggest actions that you and I can do to reduce global warming. The first thing that we can all do is elect politicians who acknowledge the global warming problem and have practical solutions. It sounds really easy, but every 4 years here in the United States, we kind of change our minds. It's working, it's not working. It's a Green New Deal, it's the Green New Scam. Characterizing these renewables as a scam is candidly insulting and ignorant, and it's anti-science. It's not helping, it's hurting. Solar and batteries with wind, but they're by far the cheapest generation sources. Solar in particular, because it's a mass production thing. The cost of solar panels keeps going down. The cost of batteries are going down even faster. And these solar and battery combinations can be deployed very quickly and near or on the buildings that need the power. Or they can be on community solar places or on rooftop parking garages. Easy to deploy, fastest, cheapest. And you got to remember that whatever the trend is right now for demand in electricity, it's going to go up even faster. And the utilities are investing on these technologies, and it's raising electric rates. But artificial intelligence, electric vehicles, heat pumps, it's all going to mean, as we move towards these more efficient, cleaner, less expensive technologies, it's all going to mean we're using more electricity. And we're going to need that power, not in 10 or 15 or 20 years, but we're going to need that over the next 5 years. Now, the other thing that you have to watch out for, be sensitive to this, because this is the economic reality. Incumbent fossil fuel companies and utility industries, they're profit-oriented. They're companies. I understand it. They're not motivated to reduce costs at all. Zero. They may talk about reducing costs, but they're not going to do things that are going to reduce their profits. And what's happened in the utility industry, that these utilities have captured the regulators with lobbying dollars. It's something called regulatory capture. They spend tons of money on lobbying, and the money comes from the ratepayers, and they're able to basically change the politics and get legislators and governors and public utility commission to do things that don't make sense, that aren't really reducing costs, but are going to be better for utility profits. Now, the utilities, they love to build expensive things because they get a guaranteed profit on expensive things. And the most expensive things that they can build are long-distance transmission lines and upgrades to the local power lines and distribution system. That's why electricity is so expensive in California and going up really fast everywhere else, because the utilities are saying, we need lots more power. And in order for us, the utilities, to provide that power, we need more transmission lines, more poles and wires. That raises rates. Now, there's an alternative to that, obviously. put the solar power plants and the batteries on the buildings that need it. But they don't want to do that. They don't make profits by doing that. They lobby the regulators to prevent that. And this is why, when you look at this graph, California's trends for electricity costs are just going up faster and faster because the utilities are overspending on poles and wires, spending on their infrastructure, not homes and businesses and corporations that are actually putting the solar and the batteries on their facilities themselves. So I'm not saying it's impossible. I'm not saying it's terrible. Just be skeptical of solutions that come from biased politicians and incumbent industries. Just be skeptical. All right. Next thing we have to do is we have to support timely and economic engineering-based solutions. Timely, because if the solutions aren't working now and are ready to scale or already scaling, we can't count on those solutions to be here over the next 5 to 10 years, certainly not as quickly as we need it. So the only thing that's really going to work are things that are scaling up right now. That's why nuclear fusion, almost impossible. Nuclear fission, really, really difficult. Solar, wind, and batteries, they're scaling like crazy. Now, we also need solutions that are cost effective. And, it's interesting how the scaling speed and the cost effectiveness go together. If it's cost effective now, they don't need a lot of incentives. And there's a shortage of incentive money. And that's why these things scale up so quickly, because just regular commerce can take care of that. It's capitalism. And that's capitalism even on your home when you're putting in solar and batteries. You say, hey, I'm paying 62 cents a kilowatt hour for electricity. I can put in solar and batteries for 10 cents. I'm going to save a lot of money. Why that's taking off. And the last thing to keep in mind is we want engineering-based solutions that are proven to ramp up quickly. We don't have time for science projects. That's why I'm so skeptical of nuclear fusion. It's a frickin' science project. Scientists have been working on this since the 50s and the 60s, and we're still 25 years away from economically scaling nuclear fusion. The current fusion plants that I see great press releases on are they cost tens of millions of dollars on a test basis, and they produce the net amount of energy you get from lighting a match. So not even close to being there. The final thing you can do is take your own personal energy efficiency and electrification actions. Do things yourself. Install rooftop solar if you have a sunny roof. Install a battery backup system. Convert your heating and cooling in your home to a heat pump HVAC system. When your hot water heater dies, put in a heat pump water heater. Don't just replace it with another natural gas heater. There's great incentives for all these things. Consider an EV. Well, there were great incentives here in the U.S. until last month, but it makes sense to, in many cases, even though the EVs are more expensive, the maintenance costs are lower, and if you have an inexpensive place to charge them up, or if you can charge from rooftop solar, makes total sense. So what's really cool about the whole transition of our energy future is these personal actions can save you money if you do the right things, especially if you're in a state with lots of sun or good energy efficiency incentives. It's often the case that solar and batteries are more affordable than conventional fossil fuels. Solar and batteries are much more affordable than buying utility power forever, even though those prices keep going up. So whether you're a home or a business, you can save a lot of money and help reduce global warming at the same time. And that's how the energy transition economically scales. All right, that's all the time we have on this week's Energy Show. Thanks to all of our listeners for tuning in. And if you miss any of today's show, you can go to our website at energyshow.biz and listen to the podcasts.
Thanks for tuning in to this week's Energy Show.